Hey all, welcome back. We're still working with the chain rule, and on tonight's homework we're going to focus on some of the more complicated ones, kind of like we had at the very end of the homework 3-1. Number 1 says, let f and g be functions defined in the table, determine each of the following. So if the function capital F is f of x, find capital F prime of 2. So we're looking for the instantaneous rate of change of this composite function when x is 2. So first, let's find the derivative of f of x. So this is a composite function, and so we're going to have to use the chain rule, where the outside function is f of x, and the inside function is actually also f of x. So the derivative of this capital F, and this is not a typo, this capital F is just a different function rather than the lowercase f, is equal to the derivative of f, so f prime of whatever's inside the parentheses, in this case that would be another f of x, times the derivative of the inside, which is f prime. So if we want to compute f prime of 2, or capital F prime of 2, or the instantaneous rate of change of f at 2, capital F, we're going to first evaluate f of 2 inside of, or here, let's go back to the color scheme. We're going to substitute in 2 for every instance of x that we see. So here we have f of 2 times f prime of 2. And all these values will be gotten from the table. I'll do this as 2 separate steps. Let me move this over here, because I want to evaluate this f of 2 first before trying to do too much at once and doing the composite's value. So first I'll evaluate the f of 2 and f prime of 2, and we can find those values right here. Here's f prime of 2, here's f of 2. So f prime of 2 is going to be f prime of whatever f of 2 is, and in this case we can see f of 2 is 1, times f prime of 2, which we can see is 5. So the last thing here before we get our final answer is going to be to find f prime of 1, and we can see f prime of 1 here, it's 4. So f prime of 2 is going to be 4 times 5, so capital F prime of 2 is 20. Letter B is a very similar setup here, except we're dealing with the g functions, and we're going to find capital G prime at 3. So the slope of the capital G function at x equals 3. Our outside function here is the same as our inside function, which is g. So we'll work this out pretty much the same way we did the last one. So capital G prime is going to be g prime of g. Kind of sound like a crazy person as I'm reading this, times g prime. So g prime of, in this case, 3 will be g prime of g of 3 times g prime of 3. So now we'll go ahead and take a look at the table to see where we're going to get these values from. So we have g prime of whatever g of 3 is, and we can see g of 3 right here, and we might as well also highlight g prime of 3, which is 9. So so g of 3 is 2. Oops. And g prime of 3 is 9. So now I'm going to evaluate g prime of 2, which I think, no, we didn't do that one, is 7. So g prime of 3 is 7 times 9, and 7 times 9 is 63. So capital G prime of 3 is 63. So the derivative of capital G at x equals 3, the instantaneous rate of change at x equals 3, is 63. Number 2 is a kind of similar problem here, but instead of being given a table, we're given a graph of both f and g. So we'll be pulling the values from the graph rather than from the table. And I think what I might do here, first of all, let me highlight the different functions here. So here's g, just to make this a little easier to see. And then here is f. Let me pick a different color here so we don't mix these up. Okay. So what I think might be a smart thing to do here is to find all the slopes first before we start answering any of these questions. So that way we have kind of a bank of values to choose from, and that way we don't have to keep going back and forth to the table. So I think I'll put the f slopes, maybe I'll put those down below, or maybe I'll just do them both down below. So from negative infinity, or I guess like whatever this is, to 0, it's a little hard to tell here, but I'm going to go ahead and assume this slope is going to be down 1 over 3. So right here, f prime is from here to here is down 1 over 3. And then from 0, maybe I'll partition it like this. From 0 to 2, the slope is up 1, 2, 3, 4 over 2. So 4 over 2 reduces to 2. And then from here, well, it looks like until the end of the graph, it looks like we're going down 1 over 4, so negative 1/4. Okay, now let's take a look at the slopes of g. We'll need those. So g prime, we don't have anything before 0 or to the left of 0, so it's just, there's not going to be any slope there. And then from 0 to 2, looks like we're going down 1, 2, 3 over 1, so negative 3. And then from 2 to, well, the end of the graph here, whatever that is, we're going up 1, 2 over 3. So my slope is going to be 2/3. Okay, so I just wanted to write those down so that when we have to evaluate some of these derivatives, we don't have to keep going back and recalculating all the slopes. All right, so let's take a look and see what we got over here. If f and g are functions whose graphs are shown, let u, so let's go ahead and make sure we take a closer look at that. Well, yeah, u is f of g, v is g of f, and w is g of g. So first we want to find u prime 1. So we want to find the derivative of u when x is 1. So first let's find u prime. U prime of x will be the derivative of f with respect to g times the derivative of g. So u prime of 1 will be f prime of g of 1 times g prime of 1. So if I substitute that in and evaluate, first g of 1, well, where x is 1 is right here, and we can see the value of g is going to be 3. And the slope there, we already computed, so we don't have to redo that, is negative 3. So now let's evaluate f prime of 3. So if we look at where 1, 2, 3 is, the derivative of f at 3 is negative 1/4. So the derivative here is going to be positive 3/4. For letter B, we're trying to find the rate of change of v when x is 6. So first let's find the derivative of v. V is g of f of x. So our derivative is going to be g prime, the derivative of g of f of x, times the derivative of f. And now if we want to evaluate that at 6, let's go back to the graph here, and I'm going to erase all these extraneous little points and stuff that I have on here. X equals 6 is 1, 2, 3, 4, 5, 6. Here's where 6 is. So we're going to say g prime of f of 6 times f prime of 6. First, we'll evaluate those f's. So f of 6 is 2, and f prime of 6 is negative 1/4. Yeah, recall that we found all the slopes at the beginning, so I'm just kind of looking right here. Okay, so g prime of 2, if we go to 2, let's see, g's derivative at 2 is going to be negative 3. So this will be negative 3 times negative 1/4. Did we get 3/4 again? Hold up, let me take a closer look at this. Yeah, typically these values are not going to be this. Oh, I see what I did. Oh, goodness. This little point here is actually a point on G, not on F. Oh, my bad, y'all. So the point is actually going to be up here. It's a little hard to tell what that point's going to be. But if we're saying the slope is down 1/4, then that means we must have gone down 3/4 there. So this would be like 1, 2, 3 and a fourth. So 3.25 would be that value, not 2. So let me fix that. 3.25. Okay, so let's go to 3.25 and see what the slope is there. So at 3.25, 1, 2, 3.25, the slope of G is 2/3. So yeah, this should be 2/3. Okay, yeah, I knew something wasn't right about that. Okay, so we got negative 2/3 and negative 1/4. We're going to multiply those together to get our final answer for part B here. So we get 2/12, which reduces to 1/6. And nope, I made another error here. Geez, I'm on a roll here with this B. This should actually be positive 2. I'm not sure why exactly I put. Oh, you know what? I think I just didn't erase the negative from earlier. So yeah, this should actually be negative 1/6. I apologize for all the mistakes there, but I think we've got the right answer now. Letter C. Let's see if we can get through this one without any errors. Maybe I should be taking this a little slower. Okay, we want first the derivative of W. Now W is g of x, so that's going to be g prime of g of x. Let me zoom in here so I can fit this in here. Times the derivative of g. So now if we want to evaluate that when x is 1, I'm just going to rewrite this, but replace all the x's with 1. I'm going to have to zoom out here so I can actually see the graph. I'm going to take this one a little slower so I don't make the same mistakes I made in the last one. So first I'll evaluate g of 1. Now g is the purple graph. Make sure I get that straight. F is the blue one here. I tried to color code them earlier. It still ran into problems. So make sure you're being extra careful here. Almost wish I had these on separate grids, but what can you do? So yeah, g of 1, if we look at g when x is 1, we see g of 1 right here. Just double check, we're on the right curve here. Yep, is 3. So times g prime of 1, the slope there we already found out was negative 3. So now we'll go ahead and evaluate g prime of 3. So when x is 3, 1, 2, 3, g's slope is 2/3. So 2/3 times negative 3. So this is going to equal negative 2. So that's the slope of function w when x is 1. Okay, yeah. Not sure why I struggled so much with that second one. I think part of the problem is just me talking while I'm working. But that's what I'm trying to do here, is give you the explanation and kind of narrate my thoughts as we go. Okay. Number 3 says determine the derivative of the given function. So this is just real kind of straightforward. Find the derivative using the chain rule kind of problem. So the outside function here. So A, we've got cosine of 5x squared plus 2x. Our outside function, let's see, what colors did I use already? I'll try to stay consistent here. So green on the outside, yellow on the inside. So we've got green on the outside, that's our cosine. Yellow on the inside, that's going to be a 5x squared plus 2x. So first we'll differentiate the cosine x. And we know the derivative of cosine is the opposite of sine. Then we're going to differentiate the inside function. And the derivative of 5x squared is 10x. The derivative of 2x is 2. Make sure you put parentheses around that. Otherwise, you're going to run into an order of operations problem. And that's our derivative. B. For B, you guys know, hopefully at this point, how I feel about this whole notation with the exponent right after the function. I'm going to rewrite this as y equals secant to the 9th power. And writing it this way, I think, makes it a little bit more obvious that x to the 9th is my outside function, and secant x is my true inside function. So I'm going to differentiate the x to the 9th first. So y prime is 9, using the power rule here, times that expression to the 8th power. That expression being secant x times the derivative of secant, which is secant times tangent. And there's your derivative for part B. Letter C, the outside function is natural log. The inside function is 3x plus 5. So I've got y prime equals the derivative of natural log, which is 1 over x. So 1 over the 3x squared plus 5 times the derivative of that 3x squared plus 5, which is 6x plus 0. So just 6x. Okay, there's number 3. Number 4, determine the equation. Oh, another one of these of the normal line this time. Okay, so just make sure normal, get that straight, is perpendicular to the tangent line. But whether we're finding the normal line or the tangent line, we're going to approach it the same way. We are going to find a slope, or a point and a slope, and we're going to plug that into point-slope form. Y minus y1 equals m times x minus x1. So let's start with the point. To find the point, we're going to substitute in the x value that we're interested in, which is 0. So we know this is going to be 0 comma something. And we're going to plug that into the original function. So we want to find what is f of 0. And that's going to be 3 times 0 minus 5 times cosine of 2 times 0. Simplifying this is going to give me 0 minus 5 times 2 times 0 is 0, and cosine 0 is 1. So f of 0 is 0 minus 5, which is negative 5. So the y coordinate is negative 5. And now we're going to get the slope. So to get the slope, we need to first find the derivative of f of x. So f prime will be the derivative of 3x, which is 3. Then we got to differentiate this composite function. My outside function will be negative 5 times cosine, and my inside function is 2x. So the derivative of negative 5 cosine Now, let's back this up a little bit. The derivative of cosine is the opposite of sine. So the derivative of the opposite of 5 times cosine will be positive 5 times sine. So plus 5 times sine of 2x times the derivative of 2x, which is just 2. Okay, so that's the derivative of f, and now we want to compute the derivative of f when x is 0. So that's going to be 3 plus 5 times sine of 2 times 0 times 2. 2 times 0 is 0, and sine of 0 is 0. 0 times 5 is just 0. So we have 3 plus 0 times 2. So the slope of this graph when x is 0 is 3. So let's go ahead and write our slope here is 3. And now we're ready to write our final equation. Y plus 5 equals 3 times x minus 0. Oh, hold up. That's not actually our answer, because like we said at the beginning, we want the normal line. So what I just found here was the tangent line. This is the slope of the tangent line. So I actually don't want the slope to be 3. I want it to be negative 1/3. All right, that looks a little bit better. Okay, number 5 says if h is this quotient, determine the value of the derivative when x is 1. And we have a bunch of given information here. I'm sure we're going to end up plugging that in once we find the derivative. So let's work on that. Let's find the derivative. Now we do have a quotient here, so we're going to have to use quotient rule. We'll start with the derivative of the top, which is g prime of 2x times 2. So that's the derivative of the top, times the bottom, minus the top times the derivative of the bottom, all divided by the bottom squared. And I'm writing it like s squared x, but I'm kind of thinking maybe I should write it like this, just to make it a little bit more obvious what to do. So now I want h prime of 1. So I'm just going to substitute in 1 everywhere where I see x. 2 times 1 is 2. And we have 2 times 1 again over here, so we have g of 2 times f prime of 1 all over f of 1 squared. Okay, so now I'm going to make these substitutions. So f of 1 is 4. That's going to go here and here. We've got f prime of 1 is 2. That's going to go here. We've got, what else we got here? We got g of 2 is 3. That's going to go here. And finally, we've got g prime of 2. That's going to go here. So h prime of 1 will equal negative 1 times 2 times 4 minus 3 times negative 2, all divided by 4 squared. Okay, now we got to simplify that. Negative 1 times, well, 2 times 4 is 8. So we have negative 8 plus 6 over 16. So it's going to be negative 2 over 16, which reduces to negative 1/8. Number 6, I've got a bunch more derivatives here. So yeah, I'm just using chain rule, product rule, quotient rule, whatever we got to do to get these derivatives. So here the outside function see, outside I think I did green, right? Yep. Outside function is 4 times e to the x, and my inside function is sine x. So y prime will be the derivative of 4e to the x, which is, well, just that, 4e to the whatever. In this case, the whatever is sine x. Times the derivative of the whatever. The derivative of sine x is cosine x. Letter B. The outside function is natural log. The inside function is sine x. So y prime is equal to 1 over sine x times the derivative of sine x, which is cosine x. Now, this, is normally how I'm having you leave your answer here. This particular problem, though, like if this was a multiple choice question, this is going to be simplified, and it simplifies in kind of a cool way here. Cosine divided by sine. We have a function that is defined as cosine divided by sine, and that is cotangent. So the graph, this is kind of wild that the cotangent graph describes the slope of the natural log of sine x. I don't think that's very intuitive, or I don't think anyone could have predicted that without doing the algebra and proving it to be true. I mean, that's pretty cool. I'm just going to write a little note here. Wow. Okay. Yeah. Now, so I guess what I'm saying is on a multiple choice question, if you stop here, and there's no answer choice that looks like that, and there's a cotangent in there, that might not be super obvious at first, but hopefully you can see the connection between those two answers. Letter C, the outside function is 5 times sine, and the inside function is e to the x. So y prime equals 5 cosine of e to the x times the derivative of e to the x, which is just e to the x again. D, our outside function is 3 sine x. This is pretty much the same thing as the last one. Yeah, in terms of the structure of how we'll actually do this. I guess they're all kind of the same when we're working with chain rule here. Y prime is equal to 3 cosine of natural log x times the derivative of natural log x, which is 1 over x. Number 7, use the values in the chart to find this derivative. Okay, here we've got a triple nested function. So not only do we have our outside function, which is f of x, and our inside function, which is x squared, but we also have this middle function, g of x. So we're going to have to use chain rule twice here. So let's write out our derivative. Okay, so this thing will equal f prime of g of x squared times the derivative of g, so g prime of x squared times the derivative of x squared, which is 2x. So if we're trying to find it when x equals 2, we'll say that f prime of g of 2 squared times g prime of 2 squared times 2 times 2 Whatever that equals, that's going to be our answer. So 2 squared is 4. So we really have g of 4 here, and we can see g of 4 is 1. So we have f prime of 1 times g prime of 4. G prime of 4 is negative 1/2. And 2 times 2 is 4. So the last thing to use the table for is f prime of 1, which we can see here is 2/3. So we have 2/3 times negative 1/2 times 4. Let's see, 2 times 1 times 4 is going to be 8. 3 times 2 is 6. So we get negative 8/6, which reduced to negative 4/3. Number 8. Determine the derivative of this using 2 different methods. Only use the chain rule in one of them. Okay, let's start with the chain rule first. So our outside function is something squared. Our inside function is x cubed plus 2x. So using the chain rule, we've got f prime is 2 times something to the first power. I'm not even going to put the something there, so I really don't need brackets here. I think I'm going to use parentheses. Of x cubed plus 2x times the derivative of x cubed plus 2x, which is 3x squared plus 2. Okay, so that's one way to get there. That's using the chain rule. But we could also get there by simply multiplying this binomial out. Whenever you're squaring something, that means that you're multiplying it by itself. So if I multiply this out using the distributive property, I can use power rule on each of the terms. So let's see here. X cubed times x cubed will be x to the 6th. X cubed times 2x will be 2x to the 4th. We got 2 of those. So I'll go ahead and pull those together. And then finally 2x plus times 2x is going to be 4x squared. And so once we get it in this form, we can just use power rule on every term in the trinomial. So f prime will be 6x to the 5th plus 16x cubed plus 8x. And so notice here that we do get 2 different kind of looking answers here. They are equivalent. If we were to go ahead and multiply this out, which I'm not asking you to do, you would get this. So these are the same. Number 9. More derivative problems. I mean, that's pretty much, what else we got here? Is that it? Oh, this is still loading. We might have to come back to that. I'm not sure what's going to be on that last page. Let's see here. Find the derivatives for each of the following. The outside function for 9a is something to the 6th power. The inside function is 1 plus e to the 2. Whoa. Actually, the inside function is just the 2x. This one we have a middle function. Our middle function is 1 plus e to the x. Okay, so to get this derivative, we're going to have to use the chain rule, of course. So the first one will be 6 times that stuff in the parentheses raised to the 5th power. So 1 plus e to the 2x times the derivative of the middle function, that 1 plus e to the x. Now the derivative of 1 is just 0. The derivative of e to the x is e to the x, so this will be e to the 2x times the derivative of 2x is 2. Okay, b. Now this is really going to kind of put your understanding of the exponents and the notation here to the test here, because these are actually 2 different expressions. We've got cotangent x cubed, but we've also got cotangent cubed x. Whenever I see that notation, I am just going to rewrite it as, wrong place for that close parenthesis there, as cotangent of x quantity cubed. Okay, so we're going to have 2 instances of the chain rule here. For that first term, the outside function is cotangent. and the inside function is x cubed. But on the second one, the outside function is actually x cubed, and the inside function is cotangent x. So we'll do this one at a time. Y prime is going to be equal to the derivative of cotangent is negative cosecant squared. So negative wrong one. Cosecant squared of x cubed times the derivative of x cubed, so 3x squared. And so that's the derivative of this piece. We've already done that one. Now we want to find the derivative of this piece. So plus, we'll start with the outside function, which is quantity cubed. So 3 times cotangent x times the derivative of cotangent x, which we just said was negative cosecant squared. So times, and I'll put this in parentheses so it doesn't look like I'm writing minus, negative cosecant x, or cosecant squared x. Now you could probably clean this up a little bit, especially with the negatives being in there, but I'm going to leave it like this. All right, last page. Did we get it to load yet? Nope. Let me stop this and maybe refresh it. All right, got a couple more derivatives, and then, well, we got 1, 2, 3, 4 more derivatives to knock out here. Okay, so the first one, my outside function is sine x. My inside function is 2x over x squared plus 5. We're going to have to use quotient rule on that inside, but we'll cross that bridge when we get to it. So y prime is equal to the derivative of sine, which is cosine, of that quotient, times what we get when we differentiate this using the quotient rule. So the derivative of the top is 2. The derivative of the bottom is, oh no, you don't derive the bottom. I'm going to differentiate just the top on that first term. So x squared plus 5 minus 2x times, well, 2x again, all over x squared plus 5 quantity squared. D, I'm going to rewrite D. So I'm going to rewrite it as cosecant of e to the x cubed, so that you can more clearly see that our outside function is x cubed. Our most inside function is e to the x, but we do have a middle function here, cosecant. So first we'll differentiate the outside function. So y prime is equal to 3 times that stuff in the brackets there, raised to the second power. And that stuff is cosecant of e to the x. The derivative of cosecant is the opposite of cosecant times cotangent. So I'm going to put all this in parentheses, the opposite of cosecant cotangent. And in both of those, we're going to put the e to the x. Now just make sure on this last step that you're only differentiating e to the x. You don't have to differentiate e to the x twice or anything like that, even though it appears twice in this middle derivative. So the derivative of e to the x is just e to the x. Letter E. Ooh, we've got a product rule going here and chain rule. Okay, so first, for the purposes of the product rule, usually when we do the product rule, I kind of write it like this, right? The derivative of f times g is f prime g plus fg prime. And so I'm going to let this e to the f 5x be kind of like my f. And g, I don't really like using f here because the function's named f. But I'm going to stick with it, and I'll go back and erase this later, but I just want you to see like where everything's coming from. So here, f prime. Okay, this is the derivative of the actual complete function, not just this little piece here. But that's what we're going to start with, is that, so we got f prime. So that's going to be the derivative of e to 5x, which is going to be e to 5x times 5, that's f prime, times g, plus f, which is e to the 5x, times g prime. So that's going to be 1 over x squared times the derivative of x squared, which is 2x. Well, it was not as bad as I was expecting it to be. So maybe I'll make a note here just for future reference. The way we did this is we used the product rule. And finally, our last one for tonight, we've got another product rule again. So we're going to use product rule again. Okay, that e, our factors were e to the 5x and natural log of x squared, but in f, our factors are 4x cubed and natural log of sine x. So for this one, we got f prime is equal to the derivative of the first, which is 12x squared, times the second, which is the natural log of sine x. Need an extra close parentheses there, plus the first, which is 4x cubed, times the derivative of the second. So the derivative of the second here would be 1 over sine x times the derivative of sine x, which is cosine x. And there we go. That is the last one for tonight. Hopefully you've got enough practice with the chain rule to feel pretty good about it. Thanks for watching, and I'll see you next time.